My name is Professor Joseph Wunderlich, Professor of Engineering, Architecture, and Computer Science, and this is a brief lecture and an introductory course in computing, and start off here with a little bit of what I did at IBM and then talk about some other historical things in the development of processors before we talk about more recent ones in following lectures. So at IBM, I was a hardware development engineer and researcher, and we worked on SMP symmetric multiprocessing machines, USA and Germany. I wrote part of a custom kernel operating system, including the APIs and a lot of test programs to test the prototype supercomputers. These were supercomputers, mainframe supercomputers. We had vector register units we could hook onto it and do numerical computations, as well as 1,500 very complex instructions developed over many years. We could connect many of these machines together in parallel sysplex, 512 processors in the one machine that was the main machine I was working on, the System 390. And we tested these things in VLSI circuit simulation and hardware test, as well as manufacturing. And then I did a number of different specific things you can think about here if you like, switching from 32 to 64-bit processing at that time, also implementing IEEE binary floating point, which is the industry standard now, but IBM invented floating point. It was 16 to some power instead of 2 to some power in scientific notation. So I researched quite a few things, including branch prediction, verification, multiprocessor systems, and then a random number theory and a bunch of correlated ones that came up with this controlled randomness that they've patented inside of IBM. And then you can see some of the details there of other things that I did. And this is something we go into more detail in other courses on the development of the parallel processing enterprise servers. They were changed to networking, had just become popular then, so the CEO decided to say everything we're doing is networking now. Large-scale networking enterprise servers, and detail there that won't go into now. Switching from bipolar to CMOS for a number of reasons. Primarily, actually, to avoid the cooling headache of the bipolar circuits that ran very hot. And companies, large companies, and countries that run their governments with these million-dollar machines really didn't want the headache of the maintenance of all the cooling, and it really wasn't that much difference in performance over time. Took a little bit of a performance hit when we went to CMOS inside of IBM, but it was worth it for everybody involved. It's what the market demanded and the customers. This is a supplemental lecture to what we've already learned about CPUs and selecting processors in this introductory course. There's a couple key terms in here. SIMD means single instruction, multiple data, and that started a long time ago, although now we use it quite a bit more. We learn more about this in advanced courses that you can take with me past this course. You can read and hear about a little bit of that. And then MIMD machines, multiple instruction, multiple data. There's actually 4 Flynn classifications, and these are 2 of them. But the simplest is single instruction, single data. And then multiple instructions. Single data is more of a theoretical thing. I believe the systolic array. So the two main ones for parallel processing is the SIMD and MIMD. So you should know those acronyms. And there's a lot of historic information in these pages here. You can skim through it. I could tell you stories about the different things here, but many of it's from long ago. The IBM RS-6000, those were in Texas when I was working for IBM in New York, in the larger scale systems. And I did have some of what I developed ported to IBM Texas or Austin to run on the RS-6000. And I supervised the junior engineer over the IBM intranet. We had our own intranet for the whole world, actually. Leased optical lines between the cities and under the ocean. Just noting here, Blue Gene. It's a notable machine. I'll let you look up some of these if you like. These are becoming more historical references now. But some very early work in multiprocessing, parallel processing was, in fact, at IBM. More you can read here about clusters and other machines and DEC and Hewlett-Packard and other people doing things long ago. More reading if you like. Let's read some more here and some IEEE transactions. IEEE is the standard for most technologies, or that develops the standards for most technologies. And references, read these if you like, some more, and a little bit more.